Hi everyone, today we're going to be talking about section 11.1, three-dimensional figures and cross sections. So this three-dimensional figure off to the right, we call that a polyhedron. A polyhedron is a many-sided, actually we should say many-faced, three-dimensional figure. Okay. In this particular case, this is called a prism, but we'll talk more about the different types of polyhedrons later on. So a face is a flat surface, so 2D, two-dimensional surface on a polyhedron. Okay. An edge is where two faces meet. So if we're talking about a face, that's going to be a flat surface. So let's say this whole shaded section would be called a face. We've got one on top, one in the front, one in the back, etc. Okay. An edge is going to be where two faces meet. So this would be considered an edge. A lot of times it's going to resemble a line. Okay, so we have an edge over here. And a vertex is where three faces meet. So for example, if I've got the bottom, the side, and the front of this box, they're going to meet at this vertex over here. Okay, it's kind of like a corner point. Okay, corner's not the best, most mathematical word, but I think you get the idea. Okay, so if we're looking at this particular figure, we can count the number of faces, the number of vertices, and the number of edges. And actually, I'm going to have you guys do that for this first example. Okay, so we've got three different types of figures. This is a triangular prism. We'll give a quick definition right now. So a prism has two parallel faces called the bases. And rectangular lateral sides. So if you're looking at each of these figures, so for example, see those two triangles, they are parallel to each other, and the faces connecting them are all rectangles, okay? With a rectangular prism, they're all going to be rectangles, so we're going to skip over that. But here, this is a pentagonal prism. You'll notice the top and the bottom are parallel pentagons, and all the other sides are rectangles. Okay, so that's always going to be the case with these, but we're not so much concerned about the names and those types of definitions. All I want you guys to do is count the number of faces, the number of vertices, and the number of edges. We'll do the first one together. So a triangular prism, let's see, faces. I've got the front and the back, so that's 2. I've got this one over here, that's 3. This surface here, that's 4, and then the bottom is 5. So we've got 5 faces. Vertices are like the corner points. So I've got 1, 2, 3. In the back, we've got 4, 5, and 6. Edges are the straight lines. So I've got 1, 2, 3 on the first triangle, 4, 5, 6 on the second triangle, and then I have 7, 8, 9 as those other 3 sides. So we've got 9 total. So take a look at the remaining pictures and do the best you can to fill in the rest of the table. Go ahead and hit pause on the video. Go ahead and check your answers here. Now, you might make some observations about the way the numbers increase as you add another side basically to your figure. So a rectangular prism has 6 faces, 8 vertices, and 12 edges, and you can check the remaining answers. Now you'll notice that as the figures get bigger by one side, the number of faces increases by 1, the number of vertices increases by 2, and the number of edges increases by 3. Okay, so that's an interesting thing that happens. Now, what we want to come up with is, well, what's the relationship between the faces and the vertices and then the edges? Well, notice if I add these two, let's say our faces plus the vertices, okay? Well, it's not quite equal to the edges. Notice that 11 is not equal to 9. So I've got, let's say 11 here, and then 9. Let's look here. I've got 14 and 12. I've got 17 and 15. And then I've got 20 and 18. Now it's a little bit easier to see, oh, well, maybe there is a pattern here. If I add 2 to the number of edges, that means it's going to equal the sum of the faces and the vertices. So we actually call this formula Euler's formula, which is right below. Okay, so I know it looks like Euler. We pronounce it Euler. And he was a famous mathematician. So Euler's formula says that the sum of the number of faces and vertices is equal to 2 more than the number of edges, okay? So let's take a look at some practice problems. So to make a polyhedron-shaped game pieces using a 3D printer, Juanita enters the number of faces, edges, and vertices into the program. If she wants a game piece with 20 faces and 30 edges, how many vertices does it have to have? Well, I'm gonna set up the formula here. I've got faces plus vertices equals edges plus 2. So I know that we have 20 faces. I don't know the vertices. I know we have 30 edges plus 2. So I would have 20 plus v is equal to 32. Vertices would have to be 12. So we're able to pretty quickly figure out the number that we're looking for based off of the givens, okay? Go ahead and flip to the next page. Okay, there are 2 more problems here. I want you guys to give them both a try. Go ahead and hit the pause button and I'll put the solutions up in a minute. Go ahead and check your solutions to examples 2 and 3. All right. So the other part of this section is talking about cross sections. So a cross section is a 2-dimensional figure created when you slice a plane through a 3-dimensional figure. See the examples below. So in this figure over here, notice that you have this like pyramid type of thing. So I've got a pyramid on top and a pyramid on the bottom. And I took this plane, this is a plane, and I'm crossing it through the figure, okay? So it kind of crosses through this point over here, okay? So what it ends up creating, and this one probably isn't as good a picture as the next, but it ends up creating, I'm gonna draw this little dotted line, is, actually I should use a different color here. Actually, we'll do that. This flat surface that crosses through the figure. And in this case, it's a rectangular shape because we're crossing horizontally through this pyramid, Okay, looking at this next one, it's probably a better picture. You can clearly see, and I'll use a highlighter here, that the cross section is a pentagonal shape, so 5-sided figure, that's sliced into the 3D figure, okay? So the cross section is a pentagon. Okay. So let's take a look at example 4. What shape is the cross section if the plane is perpendicular to the base and passes through the vertex of a pyramid? So I actually need to draw a pyramid. Most of the time I will try to give you guys a drawn diagram, but it's also good for us to practice. So to draw a pyramid, we're going to draw part of a parallelogram, sort of, except 2 of the sides are going to be dotted lines, okay? Reason being, these are going to be behind the figure instead of showing in the front. Now I want you guys to see if you can find the middle point. And I like to go straight up from there, and let's go as high as we can, and that'll be the top of our pyramid. Now I'm going to take a straight edge, it's a little bit easier to draw, and we're going to connect it to each of the vertices at the bottom. So I've got 3 of the sides so far. The last side, I'm going to use a dotted line because it's behind the figure. You could use your straight edge as well. Okay, so you'll notice that we have that pyramid. Now it says we have a cross section, so I want a flat plane that's perpendicular to the base. So perpendicular means it's a right angle. I want you guys to picture a piece of paper cutting through this pyramid through the vertex. This is called the vertex. Of the pyramid. So let's see if we can draw this in. So it's kind of tricky to draw. I'm going to use a pencil. So I want to, let's see here. Let's draw my favorite way to do this is to just draw like a parallelogram cutting through. Okay. So now the question becomes, well, what does this shape look like in the actual pyramid? So we cut through with our sheet of paper. We're slicing through this pyramid. So what ends up happening is that this sheet of paper hits the pyramid all the way down this edge until this point where it meets. Notice that the paper meets the pyramid right over here and also down here. So it's going to look something like that. Okay, so we're slicing right through, and then the bottom of the pyramid, we're going to connect those 2 as well. So the sheet of paper that actually got sliced through our pyramid looks something like this. Okay, now I wish I had a lighter pen, but we'll just lightly draw that in. Okay. So if it helps, erase that original piece of paper that we drew, and it's a little bit easier to see, where you have a flat sheet of whatever, 2 dimensions, cutting through our pyramid, perfectly vertical. Okay, so what shape is this that we created? We just created a triangle. Okay, and there we go. All right, so what if we have a plane that cuts through this tetrahedron. So tetrahedron is kind of like a pyramid also, but it's only got a triangular base, and then all the sides are triangles. But we want to draw a cross section that's parallel to the base. This is a little bit easier for us to draw, I think, because I want you guys to picture a sheet of paper. Something like this. Okay. And what that sheet of paper is going to do is cut through this figure. Okay. So it's going to hit over here. And actually, it's probably easier for me to draw it without this sheet. Okay. It's going to go along each side and along the back. Now, I want you guys to notice how I drew it in relation to the base of my figure, okay? Because we had something that was parallel to the base, I wanted 3 sides that were each parallel to the sides of the base. Okay, so this figure right here is our cross section. So it's a triangular cross section. So our question was, how do you draw the cross section? Is that you want to draw lines parallel to the base, all the same distance to the base. Notice that the distance was always the same for each of the sides. Okay, so these can be a little bit tricky to draw. When you guys are doing the homework, I want you guys to just give it your best shot, okay? They won't be perfect, but that's okay. All right, now these last couple, okay, I'm gonna have you guys try them on your own and check your answers in the scanned copy of the notes, okay? So that'll be it for today. Homework is going to be posted in Google Classroom. If you have any questions, go ahead and call in during office hours. All right, guys, have a great day.